6 and a very happy Wednesday to you all. I hope you're ready for today's arithmetic. Now, being ready means that you've had a go at the questions and you're ready to review your methods and strategies with me. Well done to everybody who's being super resilient at the moment. And what that means is that lots of you are having a go. You're not giving up. You're thinking to yourself, I can do this. And you're putting your absolute all and all of your determination into really answering these questions and persevering to learn the new methods and strategies. So a big well done to all of those people who are showing resilience. Now, as always, we're going to go through the answer for each question, and then I'll remind you to pause at the end and review any methods or strategies that you need to in your own work. Okay, so let's start with question number 1 then. We've got 4,332 multiplied by 26. And I've set up the formal method of multiplication here ready for us. Going to start in the ones, so 2 times 6 is, well done, 12, and 3 times 6 is 18, well done. Add the one you carried, that's right, 19. 3 times 6 is 18, add the one you carried, again it's 19. And 4 times 6 is 24. Add the one you carried, 25. So we've multiplied everything by the 6 and in the ones. And now we're going over to the tens column, and this 2 represents 20. So I'm going to show that I'm now into the tens by putting my placeholder 0. So 2 times 2 is 4. 2 times 3 is, well done everybody, 6. 2 times 3 is 6. And 2 times 4 is 8. Okay, my final step then is to total the two amounts to give my answer. So 2 and 0 is 2, well done everybody. 9 and 4 is, good job, 13. Now I can do 9 and 1, which makes 10. Add the 6 is 16. That's much easier to do in my head. Again, 5 and 1 is 6, and I know 2 6s are 12, so that's an easy way to do that one. 8, add 1 is 9. 9, add 2 is 11. So hopefully year 6 you're in agreement with me. 112,632. Give that one a neat little tick if you've got that one, and don't forget to pause the video if you need to review your learning. Okay, I'm just going to group that together for us so we can move it. Oh, it doesn't seem to want to do it this morning. Going to try and move it out of the way. Oh, that's easier. I'll move this one over here. Okay. Right, question number 2 then. We've got 2/3 multiplied by 2/5. So when we are multiplying, do we need to convert the fractions or can they remain as they are? Well, remember, they stay exactly as they are. The only time we convert or change the fraction is when we are adding or subtracting. So how do we multiply fractions? Well, let's start with the numerator. What do we need to do? That's right, 2 times 2 is 4. And the denominator, we have to do 3 times 5, which is 15. Well remembered everybody. And then we ask ourselves the question, can I simplify? And I'm going to let you share your answer with me on Class Dojo so I can see how you've got on with that one. Okay, question number 3 then is a division question. And I've set up our bus-stop method here for us. So we are doing 6,328 divided by 14. So I'm going to start by thinking, can I divide 6 by 14? No, I can't. And then I'm going to exchange my 6 so that it becomes 63. And this is where I'm going to start to think about what I know about the 14 times table. I'm going to do some jottings over here. I know 14 times 2, 2 lots of 10 is 20, 2 lots of 4 is 28. So therefore I can also double this so that I know 14 times 4, because I can double 20 and I can double 8 to give me 56. Remember, I'm trying to get as close to 63 as I can. Now, because I know my 5 times table, 14 times 5, I can work that one out to be 70. So the closest that I can get is to 56, which is 4 times. So it goes 4 times exactly, and now I need to work out my remainder. So I'm going to count on from 56 to 63. I have a remainder of 7. So now I'm thinking, how many times does 14 go into 72? Well, I can see 14 times 5 is 70. So the closest I can get is 5 times exactly. Now I'm going to count on to find my remainder of 2. And 14 into 28 goes twice. So my answer is 452. If you've got that one year 6, give it a neat little tick. If you know that you need to review some of your learning, please pause the video now. Okay, that takes us on to question number 4 then. And I've set up the column method over here for us. And you'll see that I've deliberately not written in the second number because I'm hoping that you're going to be able to remind me of a top tip or something that I need to be cautious of when I write in that second number underneath. You're absolutely right, year 6, well remembered. This number here is in the hundreds, 151. So when I write it underneath, I need to find the hundreds column. So I've got 2,400, and I need to line up my digits and the decimal point accurately. So that's what it looks like if I've done it accurately. My decimal point is in line, my tenths and my hundredths are in line with each other, my ones, tens and hundreds are in line with each other. Remember year 6, I've seen a few people doing this and putting the decimal point somewhere over here so that it looks like this. Well, that's going to be incorrect because this 1 represents 100 and this 2 represents 2,000. So you've used the wrong place value. Okay, so let's get it back in the right place. 151.72. Okay, so when I'm adding these numbers together, I'm going to start in the ones column as we, on the right hand side, this time in the hundredths column. So 4 add 2 is 6, and 6 add 7 is 13. Then I'm going to remember to put my decimal point in. 9 and 1 is 10, add the 1 we've carried is 11. 5 and 1 is 6, add 3 is 9. 4 and 1 is 5, and 2 and 0 is 2. Hopefully you're in agreement then. 2,591.36. If you need to review your learning, please pause the video. Okay, that brings us on to number 5, which I've got down here ready for us. This time then we are subtracting, and I used your top tip of making sure my thousands, hundreds, tenths and ones are all lined up correctly and the decimal point is in the same place value. And that means I can start to subtract now, and I'm going to do that accurately. So I'm going to start on the right hand side over in the hundredths. 2 subtract 2 is 0. 7 subtract 4 is 3. Remembering to put my decimal point in. 1 subtract 6. I need to exchange. I'm going to exchange for a 10. So this becomes 11 subtract 6, which is 5. 3 subtract 2 is 1. 6 subtract 1 is 5. And 8 subtract 5 is 3. 3,515.30. Now I wonder, Year 6, can you remember the inverse? How would I check if this answer is correct? There's bonus points for anybody who can send me the inverse method and show me how they've checked this answer is correct. Okay, let's have a look then at our flashback for today. Now, question number 1, hopefully you're feeling quite confident with, because you were reminded yesterday how many degrees are in an angle, in a triangle in total. It says work out the missing angle in the triangle. Well, I know altogether, and you'll remember this from yesterday, altogether there are 180 degrees in the triangle. So I'm going to use the bar chart, bar method here to help me. Put my total at the top. I know that one angle is 52 degrees. I know another angle is slightly larger, it's 70 degrees. And I know angle W is the remaining amount of degrees. I don't know what that is at the moment. So how could I find that missing amount? The way I would do it, Year 6, and there's a few different ways, I would first of all add together 70 and 52. And you could probably do that mentally, but for those of you that prefer a jotting, 0 and 2 is 2, 7 and 5 is 12. So I know that this part here totals 122 degrees. But I still don't know this missing amount. What I can do now to find the difference is 180 subtract 122. And again, I know lots of you can do that mentally. Some of you do prefer a jotting. I'm going to do an exchange here. 10 subtract 2 is 8. 7 subtract 2 is 5. And 1 subtract 1 is 0. So therefore I know W is 58 degrees. Okay, there are other ways of doing that, Year 6, so don't be afraid or worried if you've done a slightly different method. Okay, like I said, there are other ways of doing this. Now, how could I check that answer is correct? What could I do? Well, very quickly, I can see 50 add 50 is 100. If I add 70 to that, I've got 170. 178, add 2, will be 180. So I know by adding those three together that I've got 180. So my answer is correct. Okay, now this question, the second question, may have thrown a few people this morning. So it says, how many obtuse angles, okay, so that's a key bit of information there, obtuse angles does a rhombus have? Now, for those of you who can't remember what a rhombus is, a rhombus looks a little bit like a diamond. Okay, it's a flat shape with 4 equal straight sides. Now, I think it's better if you look at the orange one and the blue one, because that's going to help you picture the angles and see them a little bit clearer in your mind. Now, year 6, can you remember what an obtuse angle is? That's right, it's an angle which is larger than 90 degrees or greater than 90 degrees, but less than 180 degrees. Let's put the degrees symbol in there for us. We've been really accurate this morning. Okay, so I'm looking for an angle that's larger than 90 degrees. So if I look at, first of all, I'm going to rotate this to help us. I'm going to look at this angle here to begin with. Okay, now I can see, let's rotate that round, that angle, oh, it's not moving with it, that's not very helpful, is it? Let's try that again, year 6. Right, leave that where it is. I can see that this angle here is less than 90 degrees. Now, an angle that is less than 90 degrees is an acute angle. So that angle is not an obtuse angle. Now, this angle that's opposite will be measured at the same size. So it can't be that angle. Now, when I look at these two opposite angles, they are bigger than 90 degrees, but less than 180. So there are two angles that are obtuse in a rhombus. Okay, let's have a look at question number 3 then. So it says, what is the ratio of squares to triangles? Now I'm just going to put squares to triangles here because I've noticed that quite a few people are sometimes doing it the wrong way round. So it might help some of us to jot down the correct way. So they want to know squares to triangles. Now I can see that this is a repeating pattern. So I've got 2 squares and 3 triangles, 2 squares and 3 triangles, 2 squares and 3 triangles. So that means I could just focus on one part of the repeating pattern. So I can see I've got 2 squares to 3 triangles. So there's my answer for question 3, 2 to 3. If you've got that one, give it a little tick, year 6. Don't forget to pause the video if you need to review anything so far. Right then, so question 4 we should all be feeling quite confident with, as this links in directly to what we've been doing in our maths lessons this week, what we've been learning about. So it says, how many millimetres are there in 1 metre? Okay, I'm going to start by thinking about what I know about millimetres. Well, I know that 1 centimetre is the same as 10 millimetres. And you can check that on your ruler, year 6. It's a good one to be able to visualise if you use your ruler at home. Therefore, I can find out 100 centimetres. Now, to get from 1 to 100, I've made this 100 times larger. So to work out the millimetres, I will also have to make this 100 times larger. And I know 10 times 100 is 1,000. It's going to be 1,000 millimetres. Okay, now let's think about what I know about metres next. Well, I know that 1 metre is the same as 100 centimetres. And therefore, if I know 100 centimetres is the same as 1,000 millimetres, I know that in 1 metre there must be 1,000 millimetres. So that one, year 6, is all about making links between what you already know. Okay, that concludes then today's arithmetic and flashback. I have some live tutorials with you today, so if there's things that you're not sure about or that you want to review with me, don't be afraid to bring your learning with you and we can recap it together. Okay, have a lovely day everybody, and I will see you very soon hopefully.